Good school too?
No.
Hey,
Yes, it is.
you're being recorded right
What
now.
about the people?
My bad, who's ever on the screen.
Yeah. Caleb, what about freshmen?
A freshman.
Freshmen better? You don't think they're cool?
Caleb.
This button. They're spreading rumors. Wait, what about Petey?
Petey, you guys, I don't think I made or went and got your copies, so I have to do that.
I'll go down.
Great.
Peter.
Great, I'm sending you something right now.
Peter, come here, man.
Tell me if you think
Petey's
it's
just
worth
sitting there.
Petey,
chatting.
go up there.
Act like you're teaching.
No, Grady, you should have
Petey's
him.
going to it.
Yeah, it's just
Let's go.
new teacher. Yeah, it's still stable. Yeah.
Teacher Petey.
Oh my God.
Yeah, Kelsey.
Peter.
That's
You
dropped your water bottle.
Peter.
Yeah.
Great. I sent you a picture.
Why'd you have to bring
Tell me
it
if it's worth it.
Shouldn't get gays.
No.
Yeah.
Okay.
Yeah.
I apologize.
Teacher Petey.
Preacher.
Where'd she go?
There you go.
Teaching us what.
Oh, Petey.
Teach us how to get freshman or no?
Get the twins.
He's got the freshman master.
Hey, there's only a certain type of groups, only certain people can do that.
Oh,
For one, right?
I guess PD's just
Two is better than one.
He's just the beast.
Hey, yo,
I learned from you.
let me hear it, right? I'm gonna make a survey right now. Is 2
Better.
Okay, what was the picture on?
I said it too.
He looks possessed.
What did you guys put it on there?
He looks
Put it on there now. Put it on there?
No.
Yes. Hold that for Sam.
I already did.
Wait, Peter, when's your birthday?
It's not gonna read that. It's like it's too better than one.
You can find it.
Better hurry, better hurry.
I'm sorry.
Just close the door.
It is too.
She's gonna kill. She's
Sit, 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 sit.
Sure?
Thank you. Without a doubt. Thank you. What took you so long? It wasn't working. I had to make it work. Yes or no?
You can just look up for it.
They're blue for some reason.
Oh, blue.
You're looking at me like that.
Oh.
I mean, I would not.
Two cans.
Yeah.
I've had to go all day. No, it is not. Blue is not better than
Go
blue.
fast.
Jason, you can't say that. 'Cause I know you.
Me fast button, don't worry. Me speedy?
Nah.
How do we only have one?
I don't think I have one.
How do we only have one class?
I don't think I like blue. I like blue. I like baby
You
butt
know, like
blue.
little separations that is here and.
I can't be separated from people.
Oh, I saw that
one. That's not real.
Okay,
There's only one there for
sorry about that.
It's always opposed like that.
It's all right, Mrs.
It's a Monday.
Okay, are we ready to get started? Two things that I want to say super quick. If you guys look in the grade book at, I'm gonna try to update grades tonight, but you're gonna see a thing that says trimester 1 grade. Did I talk to you about that?
No.
Got it up? Okay. So you guys had Mr. Seifert, right? When he's done with his grades, which he has till Sunday, I will go in and steal your percentage from his class, and that will get put in here as half of your grade. So half of your grade is already determined. And then you will
Well,
go
there goes a
on.
C plus in the grade book.
So then you will go on with that, math does it that way, where like science, I know when you take science, you get a grade for like Chem A and you get a grade for Chem B. With math, you take the first part, that percent gets put into your second part as half of your grade, and then you continue on, okay?
Well, if I didn't
So
have
if
a
you
bad teacher
see-
the first try, I would have done
If
good.
you see this, that's what that is. It's good for the kids that did well. It's not so good for kids that didn't do well, okay? The other thing I was just gonna make sure is
Not
when
fast.
you guys go to, like, let's say you got quarantined or something like
You're
that,
still doing teams?
just for videos. So, like, say today we were home, say there was a snowstorm or something, okay? Do you guys generally go into our team to get
Yeah.
to join this? Or did you also know you can go to the calendar?
I mean
And
both ways, but I usually just run it for teams because it's easier.
so if you ever can't find it under the team itself, if you go under the calendar, and sometimes you'll have to hit more or the 3 dots to get your calendar, you can join the team here too. So if we were to have a snow day, we have to have something set up by 8:30. And it could be, like, especially if we were just starting a chapter, that I would say, we're just gonna have a live team meeting at 2 o'clock or something like that.
So
Okay.
will tomorrow be a snow day?
No.
There's a school threat and there's snow coming. Come on. Come on, Nicole, figure it out. Jeez.
All right,
God.
so let's look at this. So we're gonna talk about logs today, logarithms, and this is a topic that it always goes over in Algebra 2, and Algebra 2 is going to be, or I should say logarithms is going to be on your ACT test. It also could be on like an MCA test if you guys take that. Most of you are sophomores, right? Or freshmen, some freshmen?
Yeah.
Okay, so if when you take your ACT or MCAs, you'll see logarithms on there. So they are something that is a known topic on Algebra 2, okay? So what's gonna happen today, Owen, please?
Come on.
What's gonna happen today is you're gonna have logarithms, which is going to always have a base. This B here stands for the base. This X stands for the power. And then this is what it would be equal to. So they talk about a log loop. And what it would be is this to this power, okay, B to the X power equals A. And the reason it's in a loop is that's the way you go through it. So if I was doing log base 5 of X equals 7, okay, what I would do when I do that log base, or log loop, sorry, I'd go 5 to the 7th power equals X. So this is transferring something from a logarithmic function to an exponential function, okay? They will also ask you to do it the other way today, where you start out with an exponential function, and they will ask you to put it as a logarithmic function. So if you're doing that, like let's say they give you 7 to the 2nd power equals X, okay? It would be log, your base goes right here. Your power goes right here. And then whatever it equals goes right here, okay? The base goes here. The power goes here. Whatever it equals goes here. So it'd be log, the base is 7, then whatever, I usually put the power out here, and then I put X. Everybody that's on their phones, you need to put them away on a minute. Yes.
Is this on our TT? Log with our TT?
If it's not, you will get one that will have something like this. Okay, that's a good point, because I do think I need to print another cheat sheet for you guys too. So if you look at these, this is switching from logarithmic to exponential. And from logarithmic to exponential is pretty easy. You would go 2 to the 5th power equals 32. Okay, you would go 3 to the 2nd power equals 9. 5 to the 0 power equals 1. Did you guys know that anything to the 0 power is 1? Okay. And then 3 to the x power equals 27. Okay. So let's start with this, where we're just taking something in logarithmic form and we're switching it to exponential form. So you're just basically doing this log loop. So it would be 2 to what power? 3 equals 8. Perfect. B, if you're doing the log loop, it would be 2 to the negative 4th equals 1 over 256. Do you guys get that? 2 to the negative 4th equals that. What would this one be?
4 to the 5 over 2 equals 32.
Okay. Now, do you guys understand what a 5/2 power means? Okay, here's what it means. Do you get that if you have 4 to the 1/2 power, do you get that that's the square root of 4? Do you get, like, if it's 4 to the 1/3 power, it's the cubed root of 4? Everybody understand that?
So this is equal 4.
So this is like 4 to the 1/2 power times 5, basically. Okay, 5 over 2. So you can think of the 2 on the bottom as being the half. So, and 4 to the half is the square root of 4. Okay, and then that 5 would be outside of that. So the square root of 4 is 2. 2 to the 5th is 32. Okay.
So you have that.
This is our answer for the problem. Like, this is all we had to do, but I just want to explain what the 5/2 power means. Okay. What if I had 4 to the 6/5? What root would it be? 5th root of
4
to what power? Perfect. Okay. So now we're going to go back to this one. Now, here's another thing that will happen with logs. If they do not tell you what the base is, you always assume it's 10. Okay? Every log is base 10 unless they tell you differently. So here it would be 10 to the what power? 10 to the negative 2nd equals 1 over 100. Is that easy enough?
Yeah.
Okay.
Now,
Now, if we look at this, I'm going to just remind you, when you're going from exponential to logarithmic, it's always log. You put the base here. You put the power here. And then I never know how to explain this, but it's like whatever it equals goes right here. Okay? So it would be log, what's the base of that? 4. What's the power? 3, and the base is 64. And then you can check, like 4 to the 3rd equals 64, that is what it is. Do you guys get that?
yeah.
That wasn't very convincing. Okay, let's try this again. What is our base? Our base is 9, okay, log of 9. Then I usually put the power here. What's the power? 1/2. And then whatever it equals goes right here. Okay, so the base goes here, the power goes here, whatever it equals goes here. Okay, so that if you did that log loop again, you'd go right back to that. You're just switching from one form to another in that. So this one, we would go log of what? And then I usually put the power over here. And here goes 1/49. If we look at this one, we're going to go log base what? 1/7. Power goes over here, 3, and this is 1/343. And then this last one, it would be log of what base? I put the power over here, so that's 2/3, and this is 16. Are we good on that, Kai? Everybody okay? All right, this next one, we're actually solving. So it's kind of like each of these is equal to X, okay? They don't have it that way, but that's kind of like what it is. So if you did that log loop, it would be 4 to what power equals 16? Do you guys know that? 4 to the second, right? So X would equal 2. That's what you would have to do for that one. So it's 4 to what power gives you 16? Okay. Now if we look at this next one, we're going to do this one more like we did yesterday. We would go our base, which is 1/2 to the X power equals 256. Do you guys get how I got that? Okay. Now, we could have done this up here too. We could have gotten these both to the same base like we did yesterday, like 4 to the X and 16 is 4 squared. And then do you see how X would equal 2? Most of you just did it in your head, right? But when it's something like this, it's harder to do that. So 1/2 is the same thing as 2 to the -1 power. Do you understand that? If you're bringing that 2 up to the top, it's to the -1 power. And then we still have that X. Now we have to figure out what power of 2 is 256. And if you look at our, yes.
Well, I guess it's 8.
Okay, check, is that right? How do you know that off the top of your head?
Well, I did check it on the calculator.
Okay. So if your chart that I gave you guys only goes up to 2 to the 5th, okay? 2 to the 5th is 32. 2 to the 6th is 64. 2 to the 7th would be 64 times 2, which is 128. 2 to the 8th is 256. So if it is off of this chart, sometimes you have to like keep going with it a little bit. And Dan is correct that 2 to the 8th is 256. Now, do you guys get really what we have here is 2 to the -x or -1x, however you want to think of that, equals 2 to the 8th. So can't I let -x equal 8? And then I'm going to divide by a -1, and x equals -8. Are we okay with that one? Okay. Now, if I look at this one, again, I can think of this as equals x. So I'd have 2 to the x power equals 1/32. This is already a power of 2. What power of 2 is 32? 5. Okay. So if I do this, do you guys get 1/32? If I bring that 2 to the 5th to the top, wouldn't it be 2 to the negative fifth? So wouldn't x equal a negative 5 if you just kind of get rid of those 2's? Okay, is that okay? All right, now this one, if we have it equal to x, all right, 121 to what power gives us 11?
11.
Okay,
No.
so if you think of this, what power of 11 is 121? Squared, right? So 121 is 11 squared, and then we still have that x equals 11 to the first, basically, right? So now we have 2x equals 1. And then we would just solve that and get x equals 1/2. Now, some of you might have looked at this already, and if you're good at square roots, do you guys know that the square root of 121 is 11? And square roots is 1/2. So 121 to the 1/2 power is the square root of 121, which is 11. Now this one, if we let it equal x, is basically 9 to what power is 1? Anytime this number is 1, the only way you can do that is if you have something to the power of 0. Anything to the power of 0 is 1. So this must be 9 to the 0 power. So x is 0. The only way that you can have something to a power and it equals 1 is if it's to the 0 power. Okay? Now this one is going to be 125 to what power equals 5? Do you know what power of 5 to the third is 125? And then we'd have that to the x equals 5 to the first. So wouldn't we just take 3x equals 1 and x equals 1/3? So what this means is the cubed root of 125 is 5. Okay. This one is 27 to what power is 1/3? So if we make these both powers of 3, 3 to what power is 27? 3 to the third. And what power of 3 is this when the 3's on the bottom? -1. So do you get 3x is going to equal a -1? We divide by 3, and x is -1/3. Okay? All right. So now the last thing we're going to learn today is how to graph log functions. And it's not bad, I promise. I will say this. Everybody needs a graphing calculator. And I will say this. Today is a lot easier if you have, normally it doesn't matter the calculator you have, but I will say today is easier if you have the CE version of it. But I will show you both ways. Do you guys want to come and get a calculator if you don't have one? You can use that one if you want. Does that work for all this? I have another CE version if anyone wants to use it. No? We're all good? Just mine. Don't write it. All right. So, On test days, if I don't have enough, Mrs. Beering has a whole class set of yellow ones that are older, but we can grab some of hers too. Okay, so today what we're gonna do is learn how to graph log functions. And honestly, if you're good at your calculator, it's not gonna be hard.
I'm very good.
And if you have the CE version, it's even easier. So let's go ahead. One thing I want to tell you, do you guys remember when we did exponential growth and decay functions? They either went like this and leveled out, or they went like this and leveled out. And so, do you remember how we had an asymptote with those? Was it x equals or y equals? It was y equals, whatever y equaled right here. With our log functions, our asymptote is always going to be vertical. So instead of x equals, or I'm sorry, instead of y equals, it's going to be x equals. Okay? So if you notice this, we'll talk today about the fact that this is just x. Whatever's after the log, if that is just x, automatically your your vertical asymptote is going to be x equals 0. Okay? Right here too, notice these just have an x, so there is a vertical asymptote at x equals 0. These numbers that are our bases, this is 2, 3, 4, and notice if this is greater than 1, our graph is going to come up and increase. These bases are like 0.7, 0.5, 0.1, so they're less than 1, and notice these functions come down and decrease. Okay? I was telling you guys when we did exponential functions that all of the graphs that we've done so far, the domain was all real numbers. This is the exception. Our domain today is going to depend on where our vertical asymptote is. And it's always going to be this way from that vertical asymptote. So say this went through at x equals 1. If our vertical asymptote is x equals 1, our domain would be all x's greater than 1. So our function might look like this. It would work for all x's greater than 1. Okay? Here's another thing. If we weren't using our calculators to graph these are two log things that are true. Like say I asked you to graph log base 7 of x. And I asked you just to sketch a graph, okay? If you have log of any base 1, it doesn't matter what your base is. If this is 1, it's automatically 0. Because this to the 0 power is 1. So that's how we can get 1 point easily. The other way we could do it is if it's log base 7 and you put a 7 here, 7 to what power is 7? 1. So you can get 2 points on your graph using these two properties, but honestly, the way I'm showing you, you don't even really have to think about it as long as you plug it into your graph correctly. So let's try one. Okay, so I'm first going to show how to do it for those of you that have a CE, and I'm not positive. You guys will have to let me know for like the TI 83 pluses and the TI 84s. Do some of you have those too? I'm not sure on those if you have to do it the hard way or not. It's not super hard, it's just different. So I'm going to show you how to plug this into a CE version first. So it is 4 times log base 2 of x. So if we open this up, go to our y equals. Okay, what's different between the calculators is that actually we don't, Yeah, we do. We have to go to y equals, I'm sorry. We have to clear this. What's different about the different calculators is some have a log function under math that makes this really easy. So what I want you to do is go to math, and you have to go all the way down to letter A. And
Log base.
does anyone have like a TI-84?
Yeah. It
It has that? Okay. So if you have a TI-83 plus, does anyone have that? Does it have this? Before it? Okay. Oh, I see what you're saying. Because there was a 4 in it. Okay, I see what you're saying. So Luis, on your TI-83 plus, oh, you have the 84. It does have this?
Yes.
How about an 83? And it doesn't. So it must just be the 83. Okay, so first, let's listen to what, I got to go back, what Grady just said. We're doing 4 log, so we have to put our 4 in before we go get that log thing. So we're going to go 4 math down to A, hit that, and all you have to do is put in what the base is, which in our case was what, 2? And then wasn't this X? And you're going to hit graph. Okay, that's your graph. What we care about for our assignment is we want to get at least 3 points. Okay, so here's how you can do that. Go second table. Where these are errors, that means like your graph is to the right of all these points. So if you can imagine -4, -3, -2, -1, these are all not graphed over here. So the first one we get a point at is at 0.5, okay? That tells me that my asymptote is going to be at 0, okay? Because that's the last one that is at error. And I can also, if we go back, we're going to go down. I'm going to try to find 3 points that both the x and the y are whole numbers. So I'm going to use the point 1, 0, 2, 4, and 4, 8. Do you guys understand that? I'm going to use 1, 0, 2, 4, and 4, 8. Not that I couldn't have used other points, I could have. So I'm going to go to my graph, and I'm going to put those in. So was it 1, 0,
2, 4,
2, 4,
4, 8.
4, 8? Thank you. So let's just stop there, and I'm going to help the other kids. Okay? So those of you that have the other calculator, okay? You are going to learn something just earlier than you have to, and it's called the change of base formula. So if you have 4 log base 2 of x, to evaluate that, there is what's called a change of base formula, where you can change this to the 4 is just kind of out front. And what you would do is you do log of x on top, and on the bottom would be log of whatever your base is. Okay, the 4 is kind of hanging out in front. It's log of x is on top divided by log of 2 is on the bottom. So we don't have that log function, so we have to type this in using this. So if we go to our calculators that are the 83, this is how we're going to type it in. 4 log. Your log is going to give you this parenthesis automatically. So the top one, we're going to say x, and then you're going to close that parenthesis off, and then you're going to say divided by log, and it's going to give you this, and you're going to put 2. That's the only difference. Okay, so if we go back here to our y equals, I'll actually just type it in here so you can see it without, we're gonna go 4 log of x divided by log, is it 2? Does everybody understand that? If you have the 83. And then if you hit graph, the 2 should coincide, and they do. Does everybody get that? That has the 83? Okay. So now we're going to go back here, and I'm going to give you a hint on, Caleb. I'm going to give you a hint on the asymptote. If this is just x, automatically your asymptote is going to be x equals 0. Okay? If it's just an x that the log is of, you're just going to have x equals 0. What that means, and you don't really have to graph the asymptote, but what that means is your whole graph is going to be on this side of your asymptote. Okay? So your range is going to be x is greater than 0, because we're going to use our x's on this side. And then these, oh, nope, I'm lying on that, you guys, sorry. That's your domain. And your range is what values of y you have. And for this one, you're going to assume these graphs keep going and going forever. So our range is actually the all real numbers this time. Okay? So now let's go to our graph and plot those 3 points. 1, 0 has a point, over 2, up 4 has a point, and over 4, up 8 has a point. So we can tell that this is going up. So that tells us that it's really close to the asymptote down here. Make it go 3 or 3 points, and after that last point, just guess. Do not just start your graph right here and do this. It's either going to come down or it's going to come from here and go up. And I always want my lines covering the entire graph. Okay? Questions on that?
No, ma'am.
All right, let's go to another one.
The next one. Woo! Asymptote.
Do you think we need 1 more or 2 more?
1.
1. Okay, let's go to the harder one. All right, so let's do this CE graph first. And we're going to just plug this in. The only thing is, you guys, we're going to put a parenthesis after x plus 1. And then we're going to go subtract 9. Okay, so let's go to our graph here. Let's go to y equals, clear this, go up. And we're going to go math all the way down to A. Okay, our base for this one is 1/4. So you could either go 0.25 if you wanted to, or you could go parentheses 1 divided by 4 parentheses. Then you use your, did you say do you have to use a parenthesis? You might not, because it's down like that. I usually use parentheses sometimes when I don't have to. I don't think you should have to on that, honestly, but okay, then in these parentheses is going to be the x plus 1. And then we're going to use our right arrow over and go subtract 9. And then you guys can hit graph. So this is what I was saying. I don't want your graph to look like this. It had to come down from something, okay? So let's go and look up 3 points. And I'm going to do that by going second table. And right now I'm counting by 0.5s because we did that earlier. If you ever want to change that, you can go to second window and change this to 1. And that will stop that from counting by 1s. So what this is, we have our 0, -9. I actually don't want to change my numbers on my axes. So I'm going to use the point 0, -9. I'm going to use 1, -9.5. And I'm going to use 3, -10. So most of my graph is going to be off the graph. Okay? So if I go back, I'm just going to write these numbers in. So I used 0, -9, 1, -9.5, and 3, -10. Now I'm going to explain how we do this on the other calculators. What we would type in is this. We would do log. It's going to give us a parenthesis, and we would put the x plus 1. Then we're going to go divided by log. So it's log of this divided by log of 1/4. And then at the end, you're just going to go subtract 9. Does that make sense? Log of x plus 1 divided by log of 1/4, subtract 9. So if we go back to our graph, y equals, if I plug that in, it's log x plus 1 parentheses divided by log of 1 divided by 4 parentheses, and then you'd go subtract 9. And if you notice, they are right on top of one another. Okay, so those two are the same. So if I go back here, I want to explain this. If this is x plus 1, to find your asymptote, what you do is you think, what would I get if x plus 1 equals 0? Okay, what would I get if whatever is here equals 0? And do you get if x plus 1 equals 0? What if we get x equals -1? So that is my asymptote. My domain would be x is greater than -1. And what would my range be?
All real numbers.
All real numbers.
Is that always gonna be all real numbers?
For the range, yes. For today, yes.
Oh,
So 0, -9, you guys, is down here. 1, -9.5 is here, and 3, -10 is here. And we said, oh, yes, yes, I did. Sorry. Start over. 0, -9, 1, -9.5, 3, -10. And our asymptote is at -1. So our graph has to start way up here. And then it has to go through these 3 points, and you're just kind of guessing where it goes from there. Does that make sense?
Yes, ma'am.
Okay.
When are we supposed to get snow tomorrow?
What's that?
Snow.
All right, that is your assignment. Most of these are not graphing. 4 of them are graphing.
Yo,
Okay.
snow will be better. When I run into the snow, it's just.
Yes, you will. There's only 4 graphs, though, I promise.
So then we just have to do the asymptote.
Domain and range.
Yo, why isn't Slater working? Like, do you guys know why?
No.
Maybe the fact that you asked that question could be why you have a C+.
No, it's not because of that. It's because the teacher doesn't know how to teach. I'm just kidding. He teaches, but he doesn't teach the way I learn. Other people learn out of it. Not me.
Because maybe he doesn't put up with your staff.
I don't know what's class.
Yeah.
Yeah.
Hey, yo. It's louder. Yeah. Who's this graph?
I don't get water.
No, I didn't.
Right.
Yeah.
Laura, are you doing okay?
Yeah,
Okay. Do you have access to graph paper?
no.
Do you want me to send you some?
Ow.
What's that? Do you have a printer?
Yeah,
Should I send you some like on Teams, or I'll actually send you a message on Schoology with some attached.
okay.
Sound good?
Sure, thank you.
Yeah. Do you need anything else?
I don't think so.
Okay. Sounds good.
Bye.
Bye.
It's garbage. I cannot watch people run around with a ball not touching each other.
You should have wrapped because.
I got bars.
Alright.
Oh, boys. That's-